Good day, ladies and gentlemen. Welcome to the portal, the Mathematical Science Portal. This is Sehla here. If it's your first time watching the portal, watching the videos from the portal, welcome. We welcome you here. You can go check other videos. So, okay, guys, let's talk about addition of a hydrogen and a halogen to an alkene, hydrohalogenation. So this hydrohalogenation, what is this hydrohalogenation? So it's addition of HX, right, to this group, to this functional group. Okay, so now that's what we will look at here. So very important thing, this bulletin that I've highlighted in blue, the Markov-Nikov addition of X. Okay, so we've went through Markov-Nikov's rule. Okay, it says that when we are adding an unsymmetrical molecule like HX, like this, like HX, the negative side of this molecule will go to the most substituted carbon, right? Or we can put it like this: if we are adding something like HX, the H will go to the carbon that has more hydrogens, right? So I will demonstrate that in a structure. Before I go there, let's talk about the rest of the conditions. So in hydrohalogenation, there must not be any water present inside our flask. Okay, and then the environment inside the flask must not contain any oxygen, and then the solvent that is used to dissolve the alkene, it must be a non-polar solvent. Okay, and then it happens fairly at the room temperature, so it is not really a hard reaction to do. It's quite a spontaneous reaction. So let me do a demonstration of what I mean by the Markov-Nikov addition of HX. Okay, so let's say we have a propene, right? Okay, my H there, H. Okay, so if I add HX, so what does Markov-Nikov say? Okay, well, before I even go to what Markov-Nikov says, let's do this. Here I have two possibilities where the X can go. The X can go here at 1, or it can go at number 2. Okay, so which one is the best position for our X to go there? So now here there's a possibility of two products. Okay, one product whereby we can have X here, and then the hydrogen that we have added here Okay, so let me do this. Let me color this hydrogen that I've added with green. Okay, so if this is the hydrogen that I have added and this is the X. Okay, so and now there's another possibility. So I would have okay, so this is another possibility. But this is a plus. Okay, this is a plus, right? So this is another possibility of what we can get. So I have a X at 1, and then here I have X at carbon number 2. So but which one is the most likely structure that we will get? That's where Markov-Nikov comes in. Okay guys, that's where Markov-Nikov comes in. So what does Markov-Nikov say? What do you think? So Markov-Nikov says that this X will go to the carbon that is most substituted. Okay, so if I can look at this carbon is connected to this carbon and it's also connected to this carbon, so it is connected to 2 carbons. But if I look at this carbon, which is number 1, it's directly connected to carbon number 2. So this one is directly connected to only 1 carbon, while this number 2 is directly connected to 2 carbons. So carbon number 2, it is the most substituted carbon. So meaning that the preferred structure according to Markov-Nikov, it's this one. Okay, because our X is on the carbon that is mostly substituted. Okay, so yes, they are both possible structures, but then this one is called the major product, and then this one is called the minor product. Okay, it's called the minor product. So our main product, okay, so our main product will be the major product. So if we will do these reactions and then there are more than one products, so we will have these 2 products. Okay, so we'll have these 2 products. So but the one that's gonna dominate is the major product, because according to Markov-Nikov is the one that will dominate. Okay guys, so that's all there is to it with the hydrohalogenation. Now let's go to halogenation. Okay, so in halogenation we are adding this addition of X2, to this functional group. Okay, so now also the conditions are the same as that one of hydrohalogenation. So no water must be added to our reaction flask, and if we are going to dissolve anything, it must be, the solvent must be non-polar. Okay, and then also occurs at room temperature, so it's quite a spontaneous reaction. So this one means that if I have for example, I have a molecule like this. Okay, right, plus Br2. So what's going to happen is that I'm going to add the Brs on the double bond. Okay, so I'll have, this one is the easiest one, guys. This one you must get it right. Alright, so I'll have Br here, another Br here. So at this point, the position of the Br doesn't matter. I can have a Br here, and so that I will have both Brs at the bottom or both Brs at the top. At this point, it does not matter. But later, if you're going to continue with chemistry, you will get to study branch of chemistry. We say it's stereochemistry. So in stereochemistry, the position matters. Okay, but now we don't do that, so it doesn't matter. You can put the Brs in the same side, it doesn't matter. Okay, guys, so that's all there is to it, guys. So I'll have to close this video here, and then, oh yeah, there's something that I would like to add as well. Hydrogenation of alkynes is something that I've forgotten to add. Okay, let's have a nice our nice ruler. So now, what are the conditions? The conditions is that we need heat. We need to heat our alkyne. Okay, and we need to dissolve it in a non-polar solvent. Also, we need a catalyst. All right, we need a catalyst. So, for example, if you want to take an alkyne from an alkyne to an alkane, we need the catalyst such as platinum, palladium, or nickel, Okay, so if we use this catalyst, one of them, and then in the presence of heat, we are going to reduce this triple bond to a single bond. Okay, so in later stages, maybe when you're going to do your first year, you will learn about addition of hydrogen to alkynes that does not result to an alkane, but it will move from alkyne to alkene. Okay, even here, if you add you move from alkyne, you add 1 mole of hydrogen gas using the same catalyst. If you add 1 mole of hydrogen gas, you will move from alkyne to alkane, and then you add another 1 mole of hydrogen gas, you'll move from alkene to alkane. So you don't have to know all of that. What you have to know is that when we add hydrogen gas to an alkyne using this catalyst and heat, what we get is an alkane. That's all you need to know. So that's all there is to it with additions. Okay, this is the other video that I've done before this one. You should go check out, whereby there's hydrogenation of alkenes, and then there's also hydration as the acid catalyzed hydration. So please go check that out, and don't forget to like, share and subscribe. Okay, I love you guys. Thank you.